Hi G. Thank you for your job card write-up. I have it here in front of me. It's one that you diagnosed and rectified a brake pressure fault on an Alexander Dennis E200. Um, I'm wondering if you can just talk me through your diagnostic process, please.
Sure. So just to give you a fuller picture, a vehicle came in and the driver put on the defect card that the vehicle was pulling to one side. So uh, my team leader sort of said to me, look, go and have a look at this vehicle. So I looked at the card, driver just said the vehicle's pulling to the right. So what does right mean? It didn't say near side or offside. So first thing that I did, part of my diagnosis, one, because it was brake related safety critical system, I didn't want to take it out on the road. But what I wanted to do was just sort of slightly test it in the yard where it was safe, so make sure there was no one around. What I did was basically drive the vehicle with my hands on the steering wheel, applied the brake, and I did it in a few different ways. Did it slowly, pressed it harsh, to see what was happening, just to verify the symptom was there, and the vehicle was pulling. It was actually pulling to the near side. So when you meant right, what you meant was the actual near side. So what I then did was part of my next part of my diagnosis was I wanted to do a brake test. So I took it to the rolling road, the brake tester, and I went through the complete brake test. Now the actual information that came from the brake test unit, it passed. However, what it showed in the information was there's a massive imbalance between the near side front and the offside front. So even though the wheels locked up and it achieved a brake pass, it was really high. It was actually close to fail due to the imbalance. So I knew that on the near side front, the actual brake force was far less than on the near side, sorry, than the offside. So what I then proceeded to do was to put the vehicle onto the pit. What I then did was I made it safe. So I basically cordoned the vehicle off. I had my correct PP on. I went underneath, injected the vehicle out, safely took the wheels off, and I can tell instantly when I looked that actually the near side brakes was hotter than the offside just by feel. So what I started to do was start to proceed by taking the caliper off. What I noticed was as I take the caliper off and I saw the brake pads, that on the near side that the actual brake pads were worn unevenly. It's like a wedge. So one side was thinner or thick, whichever you look at it, than the other side. So it was unevenly worn. When I looked on the offside, they were more even. So I knew that actually the brake application on the near side was working harder on the near side than the offside. So what I then did was when I took the brake pads out, I had to adjust. So when I took I backed off the adjuster, took the brake pads out. What I then did was I continued to back the adjuster off because the caliper is a two-pot piston. So it has two pots that push against the brake pad. So what I wanted to make sure is that both pistons were retracting correctly. So I pulled the adjuster right back, okay, and both pistons came back. So I then put it back on manually, wound it back on, wound it back off, and the pistons were moving. Okay, so I knew the pistons were okay. I looked at the other elements of the caliper to make sure there's no breakages, make sure that the actuator was fitted in correctly, which was all good. When I then grabbed the actual caliper to move on the sliders, what I found was one top of it was moving and the other part of the slider wasn't, meaning one element of it was partially seized. In further investigation, looking, what I actually noticed that where the rubber boot, where the sliders sit, was actually torn. I mean, I looked clearly, water ingress had got in and dirt, which is why the reason that the slider itself had become partially seized. So as the brake was being applied, what was actually happening was it was sort of going on offset, hence causing the wedge of the brake pads to wear unevenly. So what I then had to do was found that was the issue because within our depot, when it comes to brakes, they do prefer that we replace the component and not repair it. That's our company policy at this moment in time. So what I did was I actually carefully removed the brake, the caliper. I went on to the other side and checked actually if that was okay. So I checked the sliders, I checked the pistons, and they were okay. They were in good condition. So what I then proceeded to do was go to the stores, and then we had a caliper in stock anyway, so I double checked the part number against the old one to the new one to make sure it was the correct one, and then checked it up for size. That was okay. What I also got out from the stores was a complete set of front axle or brake pads. So that comes with four pads in it, two for each side. Even though the caliper was okay, brake pads must be replaced as an axle. So what I then did was I went back to the near side, I refitted the brake pads, refitted the new brake caliper and the new brake pads into it, adjusted the brake pads up to the disc. I also, when I did that, I also checked the disc, and I checked the disc for disc run out. Now, two ways we do disc run out. We used to use DTR, we don't use it as much because what we do now is we use the brake tester to see for imbalance. If it's high amount imbalance, then we just probably replace the disc because it's quicker. But the disc itself, they weren't scored. There wasn't any cracks on it, so they're both in good condition, both sides. So I then proceeded to put new brake pads on the offside as well. So the front axle had new brake pads, the near side had a new brake caliper. Both brakes were adjusted to make sure they were adjusted correctly. What we do is we usually tighten it fully up and then back it a quarter of a turn or 90 degrees, and to make sure that the disc runs freely and there's no grinding against the brake pad against the disc. Once that was done, the wheels were then fitted on. Once the wheels were fitted on, the torque procedure, company procedure, was followed, meaning that we tightened the wheel nuts. So we basically tightened them up by hand and used the torque wrench to the correct setting, which was, I believe, was 550 Newton meters. So all wheel nuts were checked. Our procedure requires us to put on a yellow tag, and then when the vehicle has done either 50 kilometers or 24 hours, we then will re-torque the wheel nuts and put into a book as well, which is what I then did. Once that was done and I checked everything was secure, I then took the vehicle back off and I redid a brake test. Okay, the imbalance has now come right down, the brakes were locking. And what we do sometimes is the brakes don't give you the readings that you need. Sometimes you need to bed the brakes in. So we then go on to a road test to warm up the brakes and then come back and do a third brake test to ensure that the brakes are to the company standard as well as the legal standard.
Excellent. And just to pick you up on something you said there, you mentioned you checked disc warping using the brake roller tester.
Yes.
Can you just explain to me whether that would be what you would see on the screen, whether that would, you mentioned it, is it imbalance?
Yes. So what we see, yes. So what we've got, our gauges, we show like a fluctuation. So what actually ends up happening is the rolling road works. So we can do it together or we can do them single. So when we do it's a set way that we do it. So the vehicle goes in, we do the offside front, then the near side front, and then we do them together. So the wheels are turning together. And then what we do is we apply the brake and then we do what's called the threshold. So we hold it. So we press it down halfway down and we hold it for around 10 to 15 seconds. And what we're then looking for is the fluctuation, and which will then show the imbalance between the near side and the offside.
Excellent. And obviously, being a bus, this vehicle, can you explain to me why we use air as a medium rather than a fluid?
So it's really designed because the vehicle, it's fit for purpose. There's advantages of air. First of all, it's free. And secondly, when we're doing components, like I mentioned about doing brake calipers and that, we don't need to bleed the system. For a vehicle that's heavy vehicle, there's so much weight that needs to be slowed down and stopped. We need a medium that's strong enough to be able to do that. With hydraulic, it can be, but it's not sufficient. It's not sufficient on its own. It would then have to be air over hydraulic. However, pneumatic on its own is sufficient to apply the force needed, like for example on brakes, to give you the force needed to slow and stop the vehicle.
Excellent. And what would a typical pressure be within an air braking system?
So usually the application could be anything from 4 bar. Okay, we usually have around 9 bar within the system, 9 to 10 bar, but depending on what we're using, it could be anything between 4 bar. Now, different places will have different actuations. So, for example, at the foot brake, okay, it's far less because all it's doing is sending in a signal. But when you go from the relay onwards, the pressure is greater because the relay receives the signal, which is a small amount of pressure. Then the air relay would then give you a greater volume of air. So if you were to do a brake threshold, for example, at the actuator, when you press the foot brake, at the actuator very close to the caliper, it could be anything up to 7 bar, depending on different manufacturers.